Here's page 7 and 8 of trigonometric functions, the last two pages. Describe the transformations which move the first curve to the second curve. So if we look at this one here, we have, let's see, we have this, and we have this. So this first one here, -1, that is a C translation. And then this one +2 here is a plus D transformation. And remember, the positive C moves it to the right, and a positive D moves it up. So basically, we're going to have 1 to the right, and we're going to have 2 up. Okay? And then the next one, it says y equals, oh, and by the way, if you want to write that as a vector, it would be 1, 2. C, y equals tangent of x to y equals 2 tangent of x divided by 2. So this here would be an A transformation, and the 1/2 here would be a B transformation. So let's see, that would be uh, multiply amplitude by 2, and B would be horizontal stretch by a factor of 2. Okay? When B is a half, then actually it gets wider. Okay, number 3, state the period of y equals tangent of x and y equals tangent of nx, where n is not equal to 0. So y equals tangent of x, the period is simply pi. Remember that the period of tangent is pi. It's different than sine and cosine. The period of tangent nx would be, we're going to use the formula, and this formula is a little bit different than the formula we're used to, right? We have b equals pi over period, okay? So let's see, the period, and instead of 2 pi, it's pi, because the period is only pi, right? We could also write it like that. So let's say that b is n, so basically the period is pi over n, okay? All right. Now we're starting section F, the tangent function. Y equals sine x, cosine x, or tangent x. Which function has a period that is half the period of the other two functions? Well, remember, the sine x function has a period of 2 pi, cosine has a period of 2 pi, and tangent has a period of pi, so the answer is tangent. Which have amplitudes of 1? Okay, well, sine and cosine both have amplitudes of 1. And remember that tangent amplitude is from -infinity to infinity. The word amplitude doesn't really apply to the tangent. Although it does have an A factor, the A factor stretches it, but the range of tangent goes from -infinity to infinity. Which has a domain that is not all the real numbers? That would be tangent, because if the domain is not all real numbers, that means that x does not have valid values for some numbers, which is called an asymptote, right? So tangent doesn't have a valid value for example, pi over 2, or multiples of, let's see, n pi plus pi over 2, okay, where n is an integer, okay? Let me rewrite the n there. Okay. Which has a range that is all the real numbers? We just talked about that. It's tangent, right? Tangent kind of looks like that. It goes from -infinity to infinity, and it's bounded on the left and right by asymptotes. So, for the general functions for sine and cosine, give the relationship between b and the period. Okay, remember it's b equals 2 pi over p. or p equals 2 pi over b. And for tangent, give the relationship between b and the period. So the difference is the tangent, the period is pi, so. Okay? All right, number 1. State the amplitude, where appropriate, of. So here, the factor multiplied times sine 4x is 1. So the amplitude is equal to 1. What about for this one? The amplitude is negative 1, right? Because the multiplier for in front of the function is negative 1. Number 2, state the period of, and then it gives us a couple different functions. This one here, the period is just going to be the regular period of the standard tangent function, which is pi, because there's no b multiplier. What about for this one? Let's see, b is equal to 2, right? So when b is equal to 2, that means p is equal to 2 pi, since this is sine, it's 2 pi, divided by b, which is 2. So that's 2 pi divided by 2 is equal to pi. So here the period is pi. Also, okay, number 3, find b given that y equals sine of bx has a period of 2 pi. Well, if the period is 2 pi, then that means that b is just equal to 1, right? Because 2 pi divided the period of 2 pi is 1. So then we're back to our old familiar sine of x, right? And remember, when you have a standard sine function, y equals sine x, the period is 2 pi, so that totally makes sense. Okay? All right, next one. Y equals tangent of bx has a period of pi over 2. So, let's see. B equals 2 pi over p. So 2 pi over 2, which is equal to 4, just equal to 4. Okay, so b is equal to 4. All right, moving on, last page. Sketch the graphs of these functions for x between 0 and 2 pi. So let's see, the first one is a 2/3 cosine of x. So what we're going to do first is we're going to draw a regular cosine function. And this regular cosine function, I'm going to, let's see, this will be pi over 2, this will be pi. So this will be 2 pi, and this will be pi, and this will be negative 1 and 1. Okay, so the regular cosine function looks like this. Okay, and then this new cosine function, which is going to be multiplied times 2/3, is like ranges between 2/3 and negative 2/3, and it has the same shape, but it's just, you know, it just doesn't go as high. It's like 2/3 instead of okay, instead of 1. Instead of ranging between negative 1 and 1, it's ranging between negative 2/3 and 2/3. Okay, so that's A. Now the next one says y equals tangent of x plus a half. Okay, so let's draw let's see, we'll draw a function of tangent. So remember, let's see, this is pi and this is 2 pi, and the asymptotes for tangent lie at pi over 2 and every pi afterwards. So those are the asymptotes, the purple lines here. And then the standard function is looks kind of like this. Okay. To the left it goes down, and to the right it goes up. And what we're going to do here is we're going to do a C translation, a horizontal translation, and it's plus pi over 2, and that's negative c, so that means that actually our c factor is negative pi over 2, which means we're moving these lines, these tangent functions to the right by pi over 2. So that would be basically one of these squares. So we're kind of moving everything over to be like this red function here. Okay, so that was C. And now we're going to do E. So E is like two translations in one. The pi over 4 is a C translation, and since it's a negative C but it's a plus pi over 4, that means C is equal to pi over negative pi over 4. And then the negative 1 at the end is a D translation. And so the D translation is moving it down, and the C translation is moving it to the left by pi over 4. So I'm going to use a little corner of this graph paper to draw one of the sine functions. Let me use this section here. So I'm going to draw axes here. I'm just going to erase this axis to make some space. Okay, so we're going to start out with a standard sine function. The standard sine function looks like, looks like that, okay? And let's see, we are going to move it down by a factor, move it down by 1. So it would move kind of like that, okay? And then we are also going to move it to the left by pi over 4. So we're going to move it, let's see, like this point, we're going to move it over by that much. Like this is pi and this is 2 pi. So pi over 4 would be like a half of one of these blocks. So that would move to there, that would move to there. Okay, and then this would move to here. And this would move to here. So that's basically where you'd end up, where that red line is. So basically you would move down 1 unit, and then you would move to the left by negative pi over 4. Okay, and that's E. Moving on. Number 5. State the maximum and minimum values where appropriate of y equals negative sine 5x, y equals 2 tangent of x, and y equals 1 plus sine of x. Okay, so this first one here, the amplitude is negative 1, but the amplitude of negative 1, as far as maximum and minimum values go, is the same as when the amplitude is 1. So it just ranges from negative 1 to 1. Okay? And then what about C? C has an amplitude value of 2. If the amplitude value is 2, that means that it ranges from negative 2 to 2. And there's no D values here, so it's not being shifted up or down. Okay, now what about this last one? Now look, there's a D value here. Although it's out front, that's D, right? So it is getting vertically shifted upward by 1. Now what about the amplitude? The amplitude is 2, so that means it ranges from negative 2 to 2. And then we are going to adjust it by plus 1D factor, so that means the minimum one becomes negative 1 instead of negative 2, and the maximum one becomes 3 instead of 2. So the new minimum maximum are negative 1 to 3. Number 6, state the transformations which map y equals sine of x onto y equals a half a sine of x. Okay, so this is a vertical stretch by a factor of 1/2. Okay, what about C? Y equals sine x onto y equals negative sine x. So this is basically, you could say it's a vertical stretch by a factor of negative 1, or you could say it's an inversion, because if you multiply by negative 1, it just flips it upside down. Okay. E, y equals tangent of x onto x, y equals tangent of x plus pi over 4. So this is a C translation, and since it's a positive pi over 4 and a negative C, that means that C is actually equal to negative pi over 4. So this would be a horizontal translation to the left by pi over 4. Okay, number 7. Find m and n given the following graph is the function of y equals m times sine of x plus n. Okay, so you can see that the D factor, which is n, let's see, where's the middle line shifted to? The middle line seems to be shifted to -3. Okay, so that means the d value is -3. Okay, we've easily found n. What about m? M is the amplitude. Okay, so the amplitude is equal to m. And we can see from the drawing that from the zero line, or from the mean line to the maximum, that's a difference of 2 units. And from the mean line to the minimum value, that's also a difference of 2 units. So it looks like our a value is 2. Okay, so that was pretty easy. Number 8, find p and q given the following graph of the function y equals tangent of pt plus q. Let's see. So the q value is the d translation, right? So let's see. Is it translated in the vertical direction? Yeah, it seems to be. Do you see this line here? This line crosses the y-axis at 1. So that means that d, which is also equal to q, is 1. So we've already found the d value. What about the p value? The p value is like the b value, right? And the b value is related to the period. How is it related to the period? It's 2 pi divided by the period. So let's see, it's 2 pi divided by, and the period here is of one of these functions. It looks like it's 2 pi, right? Because pi to 3 pi, or negative pi to pi. So the period is 2 pi. 2 pi divided by 2 pi is 1. So the b value is 1. So the p value is also 1. Okay? And that's it.